Good morning, everybody. Welcome to another topic video. It's a Saturday morning again. Seems like that's when I'm going to be doing these things. I have time. It's relaxing. I'm sitting in my home office and my little kitty cats are around, and it just feels really nice to be with you this morning. Today, I want to try to write the formulas for copper 1 Actually, I've already done this video once this morning and it didn't save. Crazy, right? Copper 1 oxide and oops, that I don't need that word there. Okay. Copper 1 oxide, and I want to compare it to the formula of, can you guess? Can you guess what I'm going to write? We had to recall that copper is a transition metal on the periodic table. Can you find it for me on your periodic table? It is my expectation that when you're listening to the videos with me, your periodic table is out, your pen is out, ready to work with the problem. Just listening is not the whole intention. It's working with the problems that I present to you. And we do these together. It's nice. So we learned the other day that transition metals feature metals that can have different charges on them. And we had to learn for the test on coming up that iron, the Fe, can be iron 2 or iron 3. And copper can be copper 1 or copper 2. We have to learn that. Few things in chemistry to learn so that we can actually have a dialogue. So we're going to compare the formulas between copper 1 oxide and copper 2 oxide using the funnel method. And so Step 1 was we write the cation. Now what's the charge on the copper? Because now we're writing a formula, so I can use the superscript for the charge. The Roman numeral is the charge on the metal. So it's copper 1 plus. Now oxide, can you look for oxide on the periodic table? Actually, I shouldn't say it that way. Can you look for oxygen? Because we notice it's an IDE. So we're not going to find an oxide on the periodic table, right? We're going to find oxygen. And because it says an IDE, that tells me it is monoatomic anion. And that means what? That means the oxygen has gained electrons in order to have the same number of electrons as the nearest noble gas. So oxygen is in column, say it, 6. How many electrons do I need to add to it to get to column 8? I need to add 2 electrons, so that means the anion oxide is 2 minus. Good job. Okay, I write my little funnel. Now, what was the analogy with the funnel? The funnel analogy is that I'm going to combine a cation and an anion, and I'm going to put them in the funnel together, and out the bottom comes one compound. That's the notion. In the elbow of the funnel, I write the charges. So copper is plus 1. The oxide's charge is minus 2. Now what's my goal? What's that term that talks about my goal in the summation of the charges? It was charge. Now charge balance. Very, very, very important concept in chemistry. Doesn't always mean that the charges are going to add up to 0, but in this case, when we're trying to make a compound, I want to do something that's going to allow my charges to add up to 0. Now we got a little problem here because oxygen's formula looks like a 0 and 0 looks like a 0, so I'm just going to write the word 0 there. Does my cation charges and my anion charges add up to 0? They don't, because I only have a +1 on the cation side and a -2 on the anion, so that certainly doesn't add up to 0. So what did we ask ourselves? We ask ourselves, what do I have to do in order for them to multiply and add up to 0? Well, I need to have 2 of whoever is giving me the +1 charge. Oh, I'm getting a text. That's nice. I'm talking to my sister. She lives in Jersey. So now 2 times +1 gives me +2, and that adds up with the 2 minus on the anion side. And do I get 0? I give myself a question mark and I can move forward. You see, a method really frees you up. A method like this, these methods like the funnel method and the what you want, what you know method, these are tools. These are tools for your toolbox. This isn't like I'm ordering you to do these things. Tools help you and they free your mind up to think of other things. So imagine if you had to hammer a nail in and you didn't have the right tool. Well, maybe it would work. You use your pliers, or you might use the end of a screwdriver, the other end, the hand end you're supposed to hold. But would it be as effective as using a hammer to put in a nail? Of course not. So in the same way, I give you these tools that you have access to no matter what the problem, no matter what is coming at you, or what I can kind of think up of a chemistry problem, and there are millions. Once you have a tool, you can do a lot of things with it. So that's why I like the toolbox idea. So this funnel is a method. It's a tool to have at your disposal. Okay, once we have charge balance, the next thing we do is we bring down the formulas. Notice at the bottom of the funnel, I do not carry down the charges. You do not ever see me put charges in a formula. That would be redundant because the charges are inherent in the formula presentation. What do I ask myself right now? I ask myself, did I have any multipliers? And the answer is yes. So the multiplier comes down and I put it as a subscript on the item that it's about. So it says I now have copper Cu subscript to O. What is my ion ratio, please? Can you write it down? Now remember, if you say ion ratio, you need to write ions. Don't forget, a number without a unit and a thing is no definitive answer, correct? Uh-oh, my cat is, I'm in my home office and she's here in the sliding door and oh my, she sees a squirrel outside. Huh. All right, ion ratio. Let's see. How many copper ones do I have? I have 2 copper 1 plus, and my anion ratio is 1 O2 minus. Sound good? When I say ion ratio, I have to write ions because there is one big difference between copper with a no charge versus copper with a +1 charge. And over here, what are we going to get on this second problem over here? We're going to get, let's try the second problem. Can you write for me the beginning of the charge on copper 2? Copper 2 is Cu2 plus. We know oxide is O2 minus. We draw our funnel. In the crook of the funnel here on the elbow, we put the charges of the cation and the anion. Do they add up to 0? We put a question mark. Does it add up to 0? And I say yes, so I'm good to go. I bring down the formulas of the species that are in the compound. I look for multipliers. What's my multipliers? I have a 1 and a 1 because a plus 2 and a minus 2 does add up to 0. So we don't have to write subscript 1. So I would not do that. I would not do that. So I'm going to erase that. All right? Because that would be redundant. I'm not going to write down an oxide unless I have an oxide, correct? So if you write something, it's implied that it's there. That's copper 2 oxide. My ion ratio, let's write it. Can you write it without me? Let's see. How many copper 2s do I have? I have 1 copper 2 plus, and I have 1 O2 minus, or oxides. So let's just finish our little line here. I have different varieties of copper, don't I? I have copper 0, which is just the metal, the amber colored metal that we all know. Then we can lose 1 electron and get copper 2 plus. Then we can lose another electron and get copper 2 plus. These are all very different, very, very different. So if we mean copper 1, we put copper 1 plus. If we mean copper 2, we write copper 2 plus. You have to be very deliberate in your articulation of what you mean, because depending upon how many electrons on the copper, you can get very different properties. So that's our Saturday morning together. I hope this was helpful, as always, and I do hope you have a lovely day. Bye now.